Yes, Romex or SE cable can be used inside of a one-family dwelling as a wiring method for a feeder to a remote panel in a separate structure which will feed branch circuits associated with the swimming pool. It's important to understand the specific requirements and limitations of both Romex, which is formerly known as non-metallic sheathed cable, and SE cable, which stands for service entrance cable, before using them for this application. Firstly, let's discuss Romex. Romex is commonly used for residential wiring because it is relatively inexpensive and easy to install. However, its use is restricted in certain locations and applications. For a feeder to a remote panel, the suitability of Romex depends on several factors. 1. The National Electrical Code, or NEC, governs the installation of electrical wiring and equipment. You'll need to reference the NEC to ensure that the use of Romex is permitted for this specific application. Look for articles related to wiring methods, specifically those covering non-metallic sheathed cable. 2. Romex is generally intended for dry, interior locations. If the feeder run involves exposure to moisture or physical damage, Romex may not be suitable. 3. The NEC specifies the allowable ampacity of conductors based on their insulation type and temperature rating. Ensure that the Romex cable you select has the appropriate ampacity for the feeder load. 4. The NEC also specifies requirements for overcurrent protection. The feeder must be protected by a circuit breaker or fuses sized appropriately for the conductor ampacity. 5. Consider the length of the feeder run. Voltage drop can be a concern over long distances. Use a voltage drop calculator to ensure that the voltage at the remote panel is within acceptable limits. Secondly, let's consider SE cable. SE cable is designed for service entrances, but it can also be used for feeders in certain situations. There are two main types of SE cable: Type C Style R, which has a flame retardant, moisture resistant covering, and Type Use, which is suitable for underground use. 1. Similar to Romex, the NEC governs the use of SE cable. Consult the NEC to ensure that SE cable is permitted for the feeder application. Look for articles related to service entrance cable and feeder installations. 2. SE cable is more resistant to moisture and physical damage than Romex. If the feeder run involves exposure to these factors, SE cable may be a better choice. 3. As with Romex, ensure that the SE cable has the appropriate ampacity for the feeder load, in accordance with the NEC. 4. The feeder must be protected by a circuit breaker or fuses sized appropriately for the conductor ampacity. 5. Check for voltage drop, especially over long feeder runs. Use a voltage drop calculator to verify that the voltage at the remote panel is within acceptable limits. Now, let's specifically address the remote panel feeding branch circuits associated with the swimming pool. 1. The NEC has specific requirements for electrical installations related to swimming pools to ensure safety. 2. The NEC requires that electrical equipment associated with swimming pools be properly grounded. The feeder to the remote panel must include an equipment grounding conductor sized in accordance with the NEC. 3. Ground fault circuit interrupter, or GFCI, protection is required for many circuits associated with swimming pools. Ensure that the branch circuits fed from the remote panel have GFCI protection as required by the NEC. 4. The location of the remote panel must comply with the NEC requirements for clearances from the swimming pool. 5. Bonding requirements are crucial for swimming pool installations. All metallic parts of the pool structure, including the pool water, must be bonded together to equalize the electrical potential. 6. Make sure to adhere to all local codes and regulations, as they may have additional requirements beyond those specified in the NEC. Now, let's delve further into the technical aspects. Understanding ampacity involves knowing how much current a conductor can safely carry without overheating. The NEC provides tables that list the ampacity of conductors based on their size, insulation type, and ambient temperature. When selecting Romex or SE cable for the feeder, ensure that the cable's ampacity is sufficient to handle the anticipated load. Also, consider diluting factors, which may be necessary if the cable is installed in conduit or in an area with high ambient temperatures. Voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for feeders and 5% for branch circuits. To calculate voltage drop, you'll need to know the conductor's resistance, the length of the run, and the current flowing through the conductor. There are many online voltage drop calculators available that can simplify this process. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protective device to trip and energize the circuit. Bonding connects all metallic parts of the electrical system to equalize the electrical potential, reducing the risk of electric shock. The NEC specifies the size of the equipment grounding conductor based on the size of the circuit conductors. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect against electric shock. A GFCI monitors the current flowing in the hot and neutral conductors of a circuit. If there is a difference of more than a few milliamperes between the two, the GFCI trips and energizes the circuit. GFCIs are required for many circuits in wet locations such as bathrooms, kitchens, and outdoor areas. They are also required for all circuits serving swimming pool equipment. Now let's talk more about specific NEC articles. NEC Article 334 covers non-metallic sheath cable, or Romex. This article specifies the permitted uses and restrictions for Romex. It also includes requirements for installation such as support, protection from physical damage, and opacity. NEC Article 338 covers service entrance cable, or SE cable. This article specifies the permitted uses and restrictions for SE cable. It also includes requirements for installation such as support, protection from physical damage, and opacity. NEC Article 680 covers swimming pools, fountains, and similar installations. This article contains specific requirements for electrical installations related to swimming pools, including grounding, bonding, GFCI protection, and clearances. When installing Romex or SE cable, it's important to follow all manufacturer's instructions. The instructions provide guidance on proper installation techniques such as stripping the cable, making connections, and supporting the cable. Also, always use the proper tools for the job. Using the wrong tools can damage the cable or create unsafe conditions. Examples of proper tools would be a cable stripper, wire connectors, and a voltage tester. When working with electricity, always take safety precautions. De-energize the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician. Local codes and regulations may have additional requirements beyond those specified in the NEC. Contact your local building department or electrical inspector to determine the specific requirements in your area. In conclusion, while Romex and SE cable can be used as a wiring method for a feeder to a remote panel, it's crucial to ensure compliance with NEC local codes and manufacturer's instructions. Attention to opacity, voltage drop, grounding, bonding, and GFCI protection is essential for a safe and reliable installation. Remember, working with electricity can be dangerous. If you're unsure about any aspect of the installation, consult a qualified electrician. Some additional considerations include the type of overcurrent protection used, whether circuit breakers or fuses, and their interrupting rating. The interrupting rating must be sufficient to handle the available fault current at the point of installation. Also, ensure that all electrical boxes and enclosures are properly sized and rated for the environment in which they are installed. In wet locations, use weatherproof boxes and fittings. Furthermore, consider the potential for future expansion. If you anticipate adding more circuits to the remote panel in the future, it's a good idea to install a panel with extra capacity. Finally, document the installation thoroughly. Keep records of all materials used, wiring diagrams, and test results. This information will be helpful for future maintenance and troubleshooting. Consider using a surge protective device, or SPD, at the remote panel to protect against voltage surges caused by lightning or other events. SPD can help to extend the life of electronic equipment connected to the panel. When running Romex or SC cable through walls or ceilings, be sure to protect it from physical damage. Use nail plates or other protective devices where the cable passes through framing members. Also, avoid running the cable in areas where it could be easily damaged, such as near doorways or in attics with heavy foot traffic. Before backfilling any trenches where SE cable is buried, inspect the cable for damage. Any damaged sections must be repaired or replaced before the trench is backfilled. When making connections to the remote panel, be sure to use the correct type of wire connectors. Use connectors that are listed and labeled for the specific type of wire being used. Also, tighten all connections to the proper torque to ensure a reliable connection. After completing the installation, test all circuits to ensure that they are working properly. Use a voltage tester to verify that the voltage at each outlet is within acceptable limits. Also, test the GFCI protection to ensure that it is functioning correctly. If any problems are found, correct them before energizing the circuit. Remember that electrical codes and regulations are constantly evolving. Stay up to date on the latest changes to ensure that your installations are safe and compliant. Sub-panels must have their neutral and ground isolated. The only location where the neutral and ground can be bonded is at the main service entrance. This prevents unwanted current on the ground, which can cause electric shock. The equipment grounding conductor should be run with the feeder conductors. The equipment grounding conductor provides a path for fault current to flow back to the source, allowing the overcurrent protective device to trip and to energize the circuit. It is important to properly size the equipment grounding conductor according to the NEC. When installing the remote panel, make sure it is accessible for maintenance and repairs. Do not install the panel behind obstructions or in locations that are difficult to reach. Also, provide adequate lighting around the panel to make it easier to work on. Consider installing a disconnecting means at the remote panel. A disconnecting means allows you to energize the entire panel for maintenance or repairs. The disconnecting means should be readily accessible and clearly labeled. If the remote panel is located outdoors, it must be protected from the weather. Use a weatherproof enclosure to protect the panel from rain, snow, and other elements. Also, ensure that the panel is properly grounded to protect against lightning strikes. When selecting the location for the remote panel, consider the aesthetic impact. Choose a location that is not visually obtrusive and that blends in with the surrounding environment. Also, avoid locating the panel in areas where it could be easily vandalized. When installing Romex or SE cable, be careful not to damage the insulation. Damaged insulation can create a shock hazard or a fire hazard. If the insulation is damaged, repair it with electrical tape or replace the cable. When running Romex or SE cable parallel to other conductors, maintain a minimum spacing between the cables. This helps to prevent overheating and reduces the risk of interference. The NEC specifies the minimum spacing requirements. Before energizing any new circuits, inspect the entire installation to ensure that it is safe and compliant. Look for any potential hazards, such as exposed wires, loose connections, or damaged equipment. Correct any problems before energizing the circuit. Remember that electricity is a powerful force. Treat it with respect and always take safety precautions. If you are not comfortable working with electricity, hire a qualified electrician.